And we are staying in the US, moving over to Chad Kiger. And Chad, you have been in many of the US plants, doing all sorts of interesting things. And I remember the last time that you had a big presentation in one of our seminars, and we were thinking, well, wireless would be great, but we can't fit it into due to, and we came up with all different reasons for not implementing it. And then you just came in there and you told us all about what installations you had already done in the US plants, where you have saved all or solved all these things that we saw as sort of showstoppers. So I have very high expectations for your presentation today.
All right. Thank you very much, Monica. I'm going to quantify that a little bit by saying I'm starting to lose my voice a little bit, so hopefully it'll hold out. I won't have any issues. But again, my name is Chad Kiger. I'm the EMC engineering manager here at AMS Corporation. AMS Corporation, we really provide I&C testing for the nuclear power industry. Most of our work is performed in plants, although we do a lot of work here in our EMC laboratory to help qualify equipment before it goes into nuclear power plants. The talk I'm going to give today is about implementation of IIoT and wireless technologies, mainly focusing in on what's been done here in the US, although there's certainly been some work we've done abroad as well. I first got started in wireless in nuclear power plants about 17 years ago. During my graduate work at Oak Ridge National Laboratory, I was working on a report for the NRC that dealt with wireless coexistence and how would technologies such as Wi-Fi, Bluetooth, and Zigbee all coexist with one another in a nuclear power plant environment, and going along and doing a bunch of simulations. And so when I came on at AMS, it was kind of fun to be able to continue some of that research and look at how these are actually going to be deployed in nuclear power plants and what some of those advantages can be. And so my talk today, I'm really going to outline several different aspects as far as the role that wireless technology can play in the nuclear industry. One is just focusing on what can it be used for, what type of applications are there, what have people been performing, and then the second aspect, which is a little bit more dear to my heart, is how do you verify that wireless technologies can safely be deployed in nuclear power plants without interfering with existing plant equipment. As several of the talks have talked about today, there's still hesitancy to deploy wireless because of the fear that it's going to cause interference. And so we go about it, and a lot of what we do is showing plants that you can safely deploy this. It's not going to interfere with the majority of equipment. For equipment that you may have more concerns for, these are ways you can address those. So I'll talk about that sort of overall in this presentation. And so first off, one of the things I'll talk about is research projects that we have conducted here at AMS. The three on this page are more focused on work we've done jointly with the Electric Power Research Institute. And so I think Steve is on this call here. He's our project manager for several of these projects, for all these projects. And these projects really looked at what's the state of wireless technology and how can it be used within the nuclear power industry. And so as it relates more to this topic, or the seminar topic, the first one here is the sensor specification project, which really dealt with what is actually out there that's viable to be used in a nuclear power plant environment. If you go and Google wireless sensors, you'll come up with thousands that are out there and available to measure temperature, contact, humidity, water. You're going to find a lot of things that can be used out there, but not a lot of those have, I'm going to say, the backing behind them to actually be deployed in a nuclear power plant environment. And so the goal of this report was to identify what's out there that could really be used in the nuclear power industry for the main types of applications that you would be really concerned about. The biggest one being vibration. Traditionally, that has found the most benefit when it comes to wireless. It's easy to deploy, and doing equipment condition monitoring of motors and pumps is something that was found to be very valuable to the nuclear power industry. And so that's where, looking at vibration, The other ones were temperature, pressure. Think about that, not so much process temperature, but what's the ambient temperature environment? Where are these devices going to be deployed? What's the temperature of this environment? Which again can be used for things such as equipment condition monitoring. There's uses for it as plants age to use, okay, what's the temperature in this room to help extend the qualified life of devices or components? To say, can we squeak out a little bit more service life out of some of these things that have been deployed that we only designed for 40 years, or well, can they go for 60? Or now can they go for 80? And the other aspect of that report was to try and develop a guideline for how do you actually install these devices? What do you have to worry about? So how do you mount them? How do you qualify them? How do you purchase them? What do you need to require in your purchase specification? So what do you need to be asking the vendor about this wireless device to make sure you understand what type of frequency it operates at, what's the actual output power level, how does it communicate? So all the backings of what do you have to do before you actually deploy these types of devices. And then another aspect of this project was to look at what are some of the electromagnetic emissions from these wireless devices. What type of RF energy do they put off? And is that going to be something that's going to be a concern for existing installed plant equipment? Kind of dovetailing with that project was the second project, which we called Wireless Technology Assessment. The goal of this project was to really look closer at what are the electromagnetic emissions from various types of mobile wireless devices, including cell phones, tablets, and laptop devices. So devices that plant personnel may be walking around with, using for electronic work packages, using just for voice or data communication, using to help troubleshoot. So what would they be carrying around, and what are the potential emissions from these devices, and can it interfere with existing plant equipment? And really part of the goals with this is traditionally, at least here in the US, they've used exclusion zones or exclusion distances to define distances that you must keep devices away from plant equipment. A lot of this spawned from walkie-talkie radios back in the 80s. So a plant may have experienced a trip because security or operations keyed a radio and tripped the unit off. So they developed, hey, we're going to keep these devices away from sensitive plant equipment by X feet, maybe 15 feet or 5 meters. Well, going along with that, they adopted this exclusion distance calculation. Well, that exclusion distance calculation assumes certain parameters, and the main one is it assumes that all that energy is at a very, very narrow bandwidth, which is true for walkie-talkie type devices. When you consider more modern wireless devices, they will typically spread the energy over a bandwidth. And so if it's Wi-Fi, it may be 20 megahertz, 40 megahertz, Bluetooth maybe a megahertz. And so you're spreading that energy over a bandwidth, which reduces the peak overall field strength. But that's not really accounted for in this exclusion zone calculation. And so one of the goals of this report was to kind of show, okay, this is the field strength that the equation assumes or calculates. What do you actually measure? And we were able to show that the emissions are well below what that exclusion zone calculation actually calculates. And so one of the efforts we're doing right now through some other DOE projects that we're working on for the U.S. Department of Energy is look at, is there a way we can adapt that exclusion zone calculation to account for the spreading of this bandwidth of these signals? So that's really what that report is. And so both those reports are published. We list the EPRI ID numbers there. So if you're a member of EPRI, you can go to the website and be able to download those reports. The one we're currently working on is one considered to be spectrum management. And so wireless is still fairly new, even though it's been around for a long time. It's still a fairly new concept for the nuclear industry. And so they haven't quite determined how are we going to actually deploy this technology. Currently, it's been more done on an ad hoc basis. Maybe design engineering chose that, hey, we want to deploy it for this particular application, or IT said we're going to deploy it for this. And so it hasn't really been a well thought through, hey, how are we going to manage this going forward? And so that's what this spectrum management guide is trying to address is as you go and plan to deploy these wireless sensors or even just wireless technology, how do you make sure you're doing it with a thought for, okay, I'm just deploying it on maybe 5 systems today. Well, I want this to be site-wide. I want to deploy 10,000 sensors. I want to have everybody have their own tablet device and cell phone device that they can use. How is that going to scale in the future? You really need to plan all that up front. So it's kind of trying to come up with a guide for how do we have to plan for these things going forward. That's what's trying to be captured in this spectrum management guide, which is expected to be published next year. Some of the other research that's been performed. So this was a project for the Department of Energy. It was completed it's been about 10 years ago now. But looking at deploying, can you deploy wireless technology in the containment of a nuclear power plant? And so simple concept, but one that people thought, hey, this can't be done. And so we were able to go and identify a use case for it. In this case, it was containment cooling fans. And so if a fan happened to be down for more than 3 days, then they'd had to shut down the plant and make the repairs and get back online. And so this plant had a history of failures. About every 5 years, they'd have a fan failure. And so it would cause them headaches and downtime to the tune of about $2 million every time this event happened, because of lost revenue from plant operating. And so we're able to deploy a vibration monitoring system on these fans so that they can detect a fan failure before it actually occurs. And so they can understand, okay, this fan is failing. They can look at the vibration data and determine what's actually failing within this fan, have all the resources lined up, have all the parts on order and ready to go, so that if it does fan or if it does fail, they can fix it within that 72-hour window so they don't have to shut down. So they can maintain power operation while they're going through and doing making the repairs to this fan. And so again, that system's been deployed. It's in both units. One unit's been deployed for about 10 years, the other unit about 8 years, and they haven't had any issues, even with these systems being in containment. And so this has included both the sensors themselves, which contain within this stainless steel enclosure, as well as the Wi-Fi access points. So again, Wi-Fi access point was installed in a stainless steel enclosure just to provide some protection against potential radiation, as well as just to contain it. If something did happen to occur, everything would be contained within this box and enclosure, and it didn't have any chance of going down into the sump and causing issues down the road. And so, like I said, the system's out there and hasn't really had any issues. So you can deploy these type of technologies without a huge effort, what I'm going to say, to radiation harden them. Like I say, it was very little, I would say, effort was put into the radiation hardening these systems. It's all commercial off-the-shelf equipment that was used to make this all possible. One of the things that I'm finding more and more in the past few years as plants look to deploy technologies is this concept of, well, we deployed a Wi-Fi system. We want that to be able to accommodate everything wireless that we want to do. A majority of the fleets within the U.S. had deployed Wi-Fi anywhere from the last 15 years to the last 3 years. And they think that that's going to be the solution that can be used for everything. However, when you go and look for wireless sensors, Wi-Fi is not really the most optimal solution for those. And a lot of that comes down to they may just not make them. So for instance, I know EDF showed the wireless gauge readers. Well, those don't operate on Wi-Fi. And so there aren't very many other options out there unless you just use a camera that can do gauge readers. And so Wi-Fi is not going to be able to accommodate that. When it comes to battery powered, everybody wants battery powered wireless sensors that will last forever. Well, when you consider Wi-Fi, the battery is going to be very limited because Wi-Fi is a very power hungry type of protocol. So it's going to limit the number of choices that you have. And so if you try and use your protocol to select or to define what you're going to use, it's great because, okay, I'm going to have the single infrastructure. It's already installed. I don't have to worry about coexistence because everything works Wi-Fi, so Wi-Fi is going to control all that. However, you're going to be limited in your solutions. You're going to be limited in the things that you can use. You're just not going to find the availability of the type of sensors that you want. On the other hand, if you let your sensor define what you use and how you go about enabling a type of application, you can select the best sensor for your application. If that's gauge readers, you can select gauge readers. If that's motor current signature analysis, you can select a sensor that can do that. If it's vibration, you can select the optimal solution for your particular application. Even when we talk about vibration, some people want the raw spectrum data. So they want the whole waveform, whereas others just want the raw RMS voltage. And so, again, the type of sensor is going to define what you actually get from that. So if you go a sensors-based approach, you're going to find the best sensor for it. However, you're likely going to have to install additional infrastructure. That may be site-wide infrastructure, or it may just be a local network somewhere in the plant, maybe around a heater drain pump or around a component cooling water system. So like I say, it kind of defines how you're going to be doing that. And so just some of the other considerations are what type of coverage do you expect to have? Again, if you're only looking to deploy these for certain pumps and motors, well, you don't have to have coverage at those locations. So you may only have to have coverage for, say, a wireless HART network over a third of your plant, because that's where you have the pumps and motors that need wireless HART data to be able to get back to your backbone from. Whereas when you deploy Wi-Fi, if that's going to be for your mobile coverage, voice over IP for operators and plant personnel with phones, it's going to have be pretty much 100% coverage. And so you have to go through and define, okay, what are all my considerations for what I want to deploy? And again, when it comes to spectrum management, understanding what frequencies are we going to be looking to put out there. If you try and stick to the 2.4 gigahertz band, well, you may have some congestion there. Like say Wi-Fi may compete with wireless HART, may compete with Bluetooth. And so you may want to try and identify, hey, can we go to a different frequency? So that's kind of what the benefit of, I know some of the sites have gone to some cellular options. Hey, they're going to a specific frequency that's for this specific application. And so by doing that, you have sort of frequency diversity, which is going to address your coexistence concerns. And so another example I just wanted to provide is when you take a look at the type of equipment that you can monitor using this type of technologies. So this is just a list of pumps and motors, valves, transformers that a utility here in the U.S. was looking to deploy these or is deploying these technologies on. And so you can see there's a lot of different systems. They're spread throughout the plant. And so they have to provide this coverage through all these different areas. Again, this was a utility that had just deployed a Wi-Fi network. And so their thought was, well, we want to deploy this for everything. We want to be able to use Wi-Fi to get all this data back to our central location, which just really wasn't practical for them. Because again, when it came to vibration, the type of vibration sensor that they wanted to use, they wanted battery powered, which you can find. However, they got hung up on a certificate protocol. And so we identified a wireless sensor that would work. It worked Wi-Fi. However, the type of security they used and the type of security that the wireless sensor used weren't compatible. And so it wasn't stringent enough for this site to be able to use on site. And so they had to go to a different solution, which they weren't expecting. Again, looking at gauge readers, they didn't have a Wi-Fi option for those. And so the solution was either we can use a Wi-Fi camera, which is going to be very overkill. You're basically going to be having to stream live footage continuously over that link, which is going to take up bandwidth space. And it's just going to be a much more expensive solution. Unless you go through and incorporate a bunch of AI into it that knows, okay, let me go through and take a snapshot or take a picture, or even keep that processing locally to the camera such that it's doing everything and it's just only transmitting back one data set. But again, that puts a lot more upfront cost into the technology solution that the site just really wasn't wanting to expend. But with all this information, with all this data, they're really wanting to have a clear understanding of what's the health of my plant. And so by knowing all the various health of the pumps and motors, valves, they can understand, okay, rather than doing just routine maintenance, rather than overhauling this pump or motor just because 2 years have been up or 4 years have been up, let's actually look at maintaining these when they actually need to be fixed. Or so doing more rather than reactive maintenance, like I say, just doing it whenever it has to be, whenever it starts to fail. And so part of the effort that went into that is, one, identifying what's actually out there. And that whole list of pumps and motors, a lot of them already have existing instrumentation. Some of that instrumentation goes back to the plant computer. Some of it just goes up to a local monitoring point. Some of it is just a local gauge that's out there. But there's already existing instrumentation that's installed that can be used. And so you want to make sure you actually do a walk down to identify, okay, what's actually out there? Where's it at? Where does it go? And then also, if you're going to instrument this with wireless technology, how do you actually install it? Is it possible to actually put a wireless sensor on this gauge, or is that gauge just inaccessible? Then you also have the challenge of, if you want to still, or if you still need to be able to see that gauge, can you actually see it, or is this wireless sensor going to prevent the operator from actually seeing those gauges? So going through and actually putting your eyes on the equipment that's out there to determine, hey, can we actually use this? And then also, as you're out there and doing the walk down, verifying the coverage. And so if you're going to use the existing system that's there, you want to be able to understand, okay, do I actually have Wi-Fi coverage at this location? Or do I have wireless cart coverage at this location? Looking and verifying that, yep, the systems I deploy are actually going to be working here. Some of the other things to look at as you're doing the walk down are, what else is around this area? Is there any potentially susceptible equipment that I have to worry about with this installation? So do I have a digital recorder that's nearby that maybe isn't associated with that system, but it's associated with a different system? So let's say you want to go through and look at what's out there that may potentially be vulnerable, and then look at the installation. Did they use proper grounding, proper shielding? Are there things with the installation that are going to potentially make it vulnerable to EMI? Again, just as you're out there and looking at, okay, what do we want to monitor? Looking to see, okay, how can we monitor that? In some instances, there are non-intrusive ways. Ideally, they'd all be non-intrusive. So a wireless gauge reader, you can put that on the existing gauge. It just senses the gauge and transmits it back. And so the only downside of that is, well, what if I had an actual just digital wireless gauge? So what if I could take the existing gauge out and put a new gauge in? So rather than having two systems there, now I just have one. And so that's where, in looking at that, you can understand, is that a route you want to go? While it sounds easy to replace a gauge in a nuclear power plant, it's really not. And so what sounds pretty simple and easy isn't always going to be simple and easy. And so there's a lot of other things that will dictate what you can and can't do. But again, you want to go through and identify, these are all the different options for these different parameters that I want to monitor. And then you go through and sit down and say, okay, which one's going to work for us? Whether it's, hey, I'm going to select the most optimal one, or I'm going to try and find one that is along a similar protocol, so that, hey, let's address all these with one protocol or two protocols, rather than having a different protocol for each individual one. And then again, when it comes to exclusion zones, everybody can do the calculation. A lot of times you'll get very, very large exclusion distances based upon the calculations. And so that's where, like I say, even with tablet devices, you can get exclusion zones up to 2 to 3 meters, which kind of makes them impractical to be used for doing operator rounds, doing electronic work packages. And so coming through and identifying ways to reduce those. And there are several different ways that can be done. One is just to use going from a what I'm going to call this safe exclusion zone approach to a risk-informed approach. And so with that, the exclusion zone assumes a certain field strength. And traditionally, it's been 4 volts per meter. Keep everything below 4 volts per meter because in the US, we tested 10 volts per meter. So that gives a level of margin. And so okay, it's been tested at 10 volts per meter. I'm going to keep everything below 4 just to have some margin. And that's what we call the safe exclusion zone. Now, you can eat into that distance by going to this risk-informed approach to say, okay, I'm not going to violate 10 volts per meter, but I'm going to take it up above 4. And so between 4 and 10, you have sort of this risk-informed approach that says, hey, I'm going to keep things here. So I'm still less than what I want to be, but I'm not going to violate what the equipment's been qualified to. And so that's just one approach that can be taken. Another approach is actually test the devices. So take a tablet, measure the emissions from it, and actually determine what's the field strength. Because as I mentioned before, the field strength is usually much, much less than what the equation calculates, all because of what the equation assumes. And so those are 2 ways that you can look at what you're going to be using in the plant to reduce that exclusion zone. The third approach is actually going to the plant and do testing. And Tom's talked a little bit about this, that they've gone in and done 4-3 testing, IC 61000-4-3 testing of installed plant equipment to see, okay, how does it respond to these wireless signals? Because in some cases, they can take field strengths well above 10 volts per meter. I've tested things in plants up to 100 volts per meter before and did not see vulnerabilities in certain switchgear type of equipment. And so there's several different ways that you can address exclusion zones. And looking at doing this, some of the approach, as I mentioned before, is to go and actually test the equipment that's installed in the plant. So going out there and actually injecting noise onto the plant equipment. Normally this is done during an outage. I've done this in the control room before, and we picked a time when the plant was completely defueled for that activity. But I have done this work when the plant's been online and operating. So we were testing some radiation monitors in the turbine building. So you can do this in situ with the plant online, although normally you do this with the plant shut down. The other opportunity is you can do it either in a laboratory, you can do it in a warehouse, you can do it in another INC shop or development area in the plant, just to verify that, yep, these pieces of equipment are immune to these levels of wireless devices. And like I said, the benefit of that is you can go to a lot higher power levels than 10 volts per meter and show that, hey, we have margin and we don't expect to see any vulnerabilities. Kind of compared to that is just regular emissions mapping, just going out and characterizing what does the environment look like. Again, as you go about trying to maintain your spectrum and understanding what's actually out there, you can characterize what the environment looks like. The data that's shown right there is you can easily see the wireless communications that are at 900 megahertz. It's very highly peaked. However, there's a lot of other ambient stuff that's out there, and a lot of that was from a relay. So a relay was degraded and failing, and you were able to capture these emissions just based upon that relay. So like I say, that's where the benefit of characterizing the environment, you can see what's actually out there. And so just in summary, like I say, you can identify that there's a lot of different sensors that are out there that can be used. Trying to weed through the different protocols and options to figure out what can be deployed in a nuclear power plant can sometimes be challenging, but there are ways to address those. As you go forward, you want to be able to understand what's the coverage of my systems, because that's going to impact what infrastructure you have to deploy. I've seen sites that deployed 180 access points and gotten the coverage they want, and other sites are deploying 450. A lot depends upon what type of coverage do they want, what type of redundancy do they want. Making sure you have a spectrum management plan in place is critical, because that's going to make sure you prevent interference among wireless devices and with plant equipment. And then there are ways of addressing interference concerns and prevent EMI from actually occurring. So with that, I think that will end it.
Thank you very much, Chad.
Thank you, Monica.
So this really hands-on information. And it's 20 minutes past 4 CET, so All questions are saved to the discussion session, and looking at schedule, we have a short round of conclusions from Arto.
So thank you everybody, especially for the presenters, but for sure for all the audience. We have had a very interesting day, and we started in the kind of a introductory part of the whole scope here. Then we were then digging into the, okay, there was the, let's say the general introduction, followed by the security issue presentations, and then then we started from the Nordics, from the Sweden and Finnish parts there, having the interesting topics of that they what is the things that they are ongoing with their plants there. And then in a way it was very nice to have then the Swedish presentations where there were the then the general things that what are ongoing and what experiments have been done there. And then it was also refreshing to have this really scoped small really this digging in how then this single project in the Loviisa plant for this LTE project was going. And like we heard, it was a really long-term effort there. I remember that when a couple of years ago we had the wireless seminar where there was then you can see that then the progress has happened in the Nordics also. So we are moving on, and then although we always say that we have the old plants and it takes time, and then there is the resistance and the reluctance of the different kind of obstacles that we think both for the regulatory and then the interference, but then the examples show that then we are moving on the direction. And then for sure we will not most likely have the, let's say, the most recent technology replacing all the equipment in the Nordics, but then we are updating and then also enhancing the functionality. And then we were moving to the international presentations, and then hearing these very interesting presentations about the offerings that is already available for the platforms, and then the IoT systems. And then like also then now Chad was then telling about then these experiments and then the exclusion zones, how they are then applied there and how it's then moving on. So in a way there is a lot, I guess there's a lot of questions, maybe some hidden, and then people think how can they then ask the questions there. But then hopefully in the discussion session, at least I have some ideas already what to ask then in the following final discussion event that we will now have there. Like Monica already mentioned, we will have then the most of the presentations then available in the Energiforsk website. And then I will compose a short summary report. So it's a kind of, it's a bit like a teaser that then you can get the summary for each of the presentations there, that you can have a kind of a compact a document that where you can first have a look, and then if you are for sure you are then encouraged to then visit and see the actual presentations then from the website. So it has been a really interesting afternoon in a way. All the presentations, I guess one of the challenges that to squeeze them into 20 minutes, and then I guess everybody would have had then the talk for an hour or a couple of hours then if we would have let them to do. But then I guess that would have been a bit heavy experience for the audience then to try to follow. But then I guess for everybody is then for the speakers then welcoming the questions even after the seminar, if you have something in your mind or it's then emerging then later when you are then melting down the the ideas and the things that you have heard today. But thank you on my behalf, and naturally thank you for Monica and Energiforsk for organizing this very nice event.
Yes, and thank you, Arto, for assisting me with the program. I also think that it's been a really interesting day, and every time we make a seminar, we say we can't have enough with presentations with the hands-on sort of descriptions of what's happening out at the plants. And even if we had 3 plants lined up after each other, the presentations were very different. So I keep the saying that you can't have enough presentations for the next seminar, but The next seminar will be moderated by somebody else because I will be leaving Energiforsk quite soon for new challenges. But it has been really interesting to be able to dig into this digitalization area, which I think is fantastic and is really an area for the future that we can use in many ways, not only to make the plants cost efficient, but also to find these new persons that we want to start working in the nuclear industry. That I think digitalization is really something that we can tempt them with to join us in the plants. So just a reminder, I will send you a link once we have the documentation on the Energiforsk web. And this morning we had a steering group meeting deciding that the theme for the next digitalization webinar in our program will be robotics. That's something to look forward to, maybe early fall or something. Don't set any date yet. So I think that's all for me. Thank you very much. So those of you who are in the US, have a fantastic rest of the day. And for those of us who are in Europe, enjoy your evening. And if you still have questions and energy to discuss, just join the discussion session, where you will be meeting with Nathan, Abhinav, and Chad. So thank you very much, everybody, and see you in the discussion channel.
Thank you.
Thank you.
Once thanks for Monica for amazingly